Hello, today we're going to be looking at exponential functions. And an exponential function is a function where a variable is in the exponent of our equation. And you can see in my first example here we have y equals 2 to the x power. And my variable x is sitting in the exponent. So my inputs are going to be the exponents. My outputs are going to be the results from those. So we're asked to graph, so I'm going to make an xy chart here. And I'll put in my usual suspects of all these x's here, and we'll see what happens. So if I put -2 in for x, so I get 2 to the -2 power. And perhaps you forgot, I'll remind you, a negative exponent indicates a reciprocal. So we're doing 1 over 2 squared, which means we get 1/4. So we have the ordered pair -2 comma 1/4. If I do 2 to the -1, that's 1 over 2 to the first. And so really that's just 1/2. 2 to the 0 power, anything to the 0 power is 1. The number 1 then, 2 to the first, that's just 2. And 2 squared, that is 4. And if I wanted to go even further, I could do 3, and 2 to the third would be 8. So I'm going to put these ordered pairs into my function, or into my graph. So I have -2 comma 1/4, that's right about there. Okay, -1 comma 1/2, that's right there. Here's 0, 1. Here's 1 comma 2, and 2 comma 4. And my 3 comma 8 isn't going to quite fit. It'll be up here somewhere. If I wanted to go to -3, that'll be a 1/8. That'll be down there. So if I go to -4, it'll be 1/16. If I go to -5, it'll be 1/32. There is no value of x that's actually going to give me a y value of 0. So what actually happens here, the x-axis plays the role of an asymptote. And here's the word, asymptote. And that is a line which a function approaches but never reaches. Okay? And so our function will get close to the x-axis, but it will never actually touch the x-axis. So to draw this appropriately, we shouldn't have this touching. It's very difficult to do that because it gets as close as it can possibly get without actually doing the touching. Come on now. There we go. And that's what this looks like. So that's what an exponential function looks like. It kind of has that little hook or curve to it as we get into the positive x's, it grows very quickly, and as we get into the negative x's, it approaches 0. So if we want to do the domain and range, the domain, well, I can put in whatever I want. So like most functions, this is all real numbers. But my range, well, I never got to 0, and I didn't do anything down here. There's nothing there. So my range are all my y's greater than 0. Let's go to the next slide. So here I have another exponential function. Notice it's changed a little bit. I now have 2 times 3 to the x. So once again, I'll make my xy chart. Not my best effort, but whatever. Okay, and we'll put these numbers in. So I have 2 times 3 to the -2 power. If I take something to the -2, again, it's the reciprocal. So I have 2 times 1 over 3 squared, which means I'm going to have 2 on top and 9 on bottom. Okay, if I do -1, 2 times 3 to the -1 power, I know it's 2 times 1 over 3 to the first, or 2/3. All right, if I put 0 in, I get 2 times 3 to the 0 power. 3 to the 0 power is 1. 1 times 2 is 2. So I have 2 times 3 to the first. That's 2, just simply 2 times 3, which is 6. And here if I have 2 times 3 squared, That's 2 times 9, and we get 18, which certainly won't fit on my graph. So let's go ahead and put these points on there. -2 comma 2 ninths, roughly there. -1 comma 2 thirds, slightly higher. 0 comma 2, there it is. 1 comma 6 puts me all the way up here. And when I get to 2, I'm going to be at 18, which is not even going to be on my iPad at this point. So this is what this looks like, and I did something I shouldn't have, because once again, I'm going to have an asymptote out of my x-axis. So we're going to get really close, but we're never actually going to touch that thing as it comes through and curves up there. Okay, and so that's what this would look like again. The negative x's are going to give us something that approaches 0, while the positive x's grow very quickly. Okay, the domain, again, all reals. The range, still y's greater than 0. Something I want to talk about real quick, though. Right here, that is my y-intercept. My y-intercept in this case is 2. Because if I put 0 in for x, right, my result is 2. So if I put 0 in for x, what that does is automatically cancels out my exponents. So like 2 times 3 to the 0 power. 3 to the 0 to anything is 1. So I'm going to have this number out front, which in this case is a 2, multiplied by 1. In my first example, it was y is equal to 2 to the x. When I put that in, when I put in 2 to the 0, I just got a result of 1, because the number out front of it was a 1. So this number out front, if I write it as y equals a times b to the x power, a is the y-intercept here. That's a quick pattern to figure out what that's going to be instantly. Okay, and we will be done.